Today we are going to learn about understanding tokenization in NLP. We will explore the concept of tokenization, its purpose, and its application in natural language processing. By the end, you'll be able to implement basic tokenization techniques using popular NLP libraries.
Tokenization is the process of converting a sequence of characters into a sequence of tokens. In the realm of natural language processing, tokenization serves as the foundation for most NLP tasks. It involves breaking down text into manageable parts, such as words or sentences, which can then be processed by machines. This fundamental step allows computers to understand and analyze language by transforming raw text into a structured format. As we delve into this topic, we'll explore various tokenization techniques, tools, and best practices, ultimately enabling you to implement these methods in your projects. Tokenization is often described as text segmentation, where a continuous stream of text is divided into discrete units, or tokens. These tokens can be as small as individual characters, whole words, or even entire sentences. The primary purpose of tokenization is to facilitate text analysis by converting unstructured text into a structured format that machines can easily interpret. As a preprocessing step in NLP, tokenization is crucial for enabling language understanding. It allows for the efficient handling of text data, making it possible to perform various NLP tasks such as sentiment analysis, language modeling, and information retrieval. Without tokenization, it would be challenging for algorithms to interpret the nuances of human language effectively. This process is particularly important in transforming raw data into useful information, laying the groundwork for more advanced text processing and analysis.
There are several tokenization techniques commonly used in NLP, each serving different purposes and offering unique benefits. Word tokenization involves splitting text into individual words, which is useful for tasks like text classification and language modeling. Sentence tokenization, on the other hand, divides text into sentences, making it suitable for tasks that require sentence-level analysis, such as translation and summarization. Subword tokenization, including methods like byte pair encoding, BPE, allows for the handling of rare words and morphological variations by breaking words into smaller subword units. Character tokenization treats each character as a token and is often used when dealing with languages that do not have clear word boundaries, such as Chinese or Japanese. Each of these techniques has its applications and use cases, and the choice of method depends on the specific requirements of the NLP task at hand. Tokenization is not without its challenges. One of the primary issues is handling punctuation, which can significantly impact the tokenization process. Punctuation marks can alter the meaning of a sentence, so deciding whether to keep or discard them during tokenization is crucial. Another challenge is the complexities of different languages, each with its own grammatical rules and structures. Ambiguities in text, such as homonyms or polysemy, can also complicate tokenization, as the same word may have different meanings depending on the context. Additionally, dealing with stop words, common words like and, the, or is requires careful consideration, as they can either be removed to simplify analysis or retained to preserve meaning. These challenges highlight the importance of selecting the appropriate tokenization technique and understanding its impact on downstream NLP tasks.
Several tools and libraries are available to simplify the tokenization process in NLP. NLTK, Natural Language Toolkit, is a popular choice for beginners, offering basic tokenization functionalities and a wide range of NLP tasks. For more advanced tokenization needs, spaCy provides faster and more efficient tokenizers, along with features like part-of-speech tagging and named entity recognition. The Stanford NLP Toolkit offers a comprehensive suite of NLP tools, including tokenization, parsing, and sentiment analysis. OpenNLP is another library that provides a variety of NLP components, including tokenizers. When choosing the right tool for tokenization, consider factors such as ease of use, processing speed, and the specific requirements of your project. Each library has its strengths and is suited to different types of NLP tasks, so selecting the appropriate one can significantly impact the efficiency and accuracy of your tokenization process. Tokenization can vary significantly across different languages, each presenting its own set of challenges. For instance, languages with non-Latin scripts, such as Arabic, Hindi, or Russian, require specialized tokenization techniques to account for script-specific characteristics. Chinese and Japanese, known for their lack of clear word boundaries, often rely on character or subword tokenization methods to effectively segment text. Multilingual tokenization tools, like Google's Sentence Piece or Fast Text, are designed to handle multiple languages, providing a unified approach to tokenization across different linguistic contexts. The importance of language models cannot be overstated, as they help capture the nuances and complexities of each language, informing the tokenization process. By understanding the intricacies of tokenization in different languages, you can ensure that your NLP models are robust and capable of handling a diverse range of text data.
Let's explore some practical examples of tokenization using Python. We'll start with NLTK, a library that provides simple and effective methods for word tokenization. By using NLTK's word_tokenize function, you can easily split a sentence into individual words. For sentence tokenization, spaCy offers an efficient approach with its sententizer and parser components. These tools allow you to break down text into sentences, facilitating tasks that require sentence-level analysis. When dealing with multilingual text, leveraging libraries like SentencePiece can help manage tokenization across different languages. Throughout this section, we'll provide code snippets and demonstrations to illustrate how these techniques can be implemented in real-world scenarios, enabling you to apply tokenization in your NLP projects with confidence.
Tokenization has a profound impact on various NLP tasks. In text classification, the choice of tokenization technique can influence the accuracy of the model, as it affects how text is represented and subsequently analyzed. For sentiment analysis, effective tokenization ensures that the sentiment-bearing words and phrases are accurately captured, allowing for precise sentiment detection. In information retrieval systems, tokenization helps in indexing and searching text efficiently, enabling quick and accurate retrieval of relevant documents. Language modeling, which forms the backbone of many NLP applications, relies heavily on tokenization to understand and predict word sequences. As a preprocessing step, tokenization determines the quality of text input, laying the foundation for all subsequent NLP processes. Understanding the impact of tokenization on these tasks is crucial for developing robust and effective NLP models.
To achieve effective tokenization, it's essential to follow best practices and consider various factors. First, choose the right granularity for your tokens, whether they're words, subwords, or sentences, based on the specific needs of your NLP task. Handling punctuation carefully is also crucial, as it can significantly influence the meaning of text. Consider multilingual requirements if you're working with text in multiple languages, ensuring that your tokenization approach accommodates different linguistic characteristics. Additionally, take into account the context and semantics of the text to preserve meaning during tokenization. Finally, evaluate the impact of your tokenization choices on downstream tasks, making adjustments as needed to optimize performance. By adhering to these best practices, you can enhance the accuracy and effectiveness of your NLP models. In conclusion, tokenization is a fundamental step in natural language processing that plays a critical role in transforming raw text into structured data. Throughout this video, we've explored the definition, purpose, and importance of tokenization in NLP. We've discussed various tokenization techniques, challenges, and the tools available to facilitate this process. Additionally, we've highlighted best practices to ensure effective tokenization and its impact on downstream NLP tasks. As you apply these concepts in your projects, remember that tokenization lays the groundwork for successful NLP applications. We encourage you to experiment with different tokenization techniques and tools, adapting them to suit the specific requirements of your tasks. Thank you for joining us on this journey to understand tokenization in NLP.